what? Deploying large-scale SSL solutions doesn't really work. 2, you could force everyone at the home page to click through to a login page. Now, I used to, believe it or not, be part of Linux's GNOME project. I used to be a UI guy way back in the day. And let me tell you, when you put a username and password form in front of someone on every single page they go to, they think, wow, I should log into that. It's like in literature, Chekhov's gun. Wow, I should really be using that thing. And banks love it when people use online banking. Because guys, you're all a pain in the ass to deal with, and they'd much rather you just go to their computers and you do the work. Wouldn't that be great? Then you just store their money, and it's wonderful. So every single time this subject that comes up, they're like, well, you know what? If we fix that, we're going to reduce the usage levels of online banking, and that will cost us money. So they don't want to do anything. And that's a position. Reasonable or unreasonable, it's a position, business decision. And so what you get is allow people to log in directly through the homepage. Question, is it possible for users on online applications to use a homepage login screen securely? And the answer is yes. 4th option. So web pages are not static documents. They're not sheets of paper. They can recode themselves dynamically to user input. Now on HTML, you have a function called iframe. Iframe is a mechanism for putting a mini window of a web browser into another page. Iframes do not need to be visible. They can be 1 pixel by 1 pixel. It's somewhat well known that you can iframe to another page and then get that other page into the browser cache. So when you go over to it, it just pops up instantly. Great. What's not well known is that you can actually have a secure link, an HTTPS link inside of the invisible iframe, and it'll work. It'll negotiate the crypto, it'll cache the contents. Why? Because as long as you're still on HTTP, you're not making any assertions about the security level of the iframe. You're just retrieving content. Browsers allow you to upgrade securely a lot easier than they allow you to downgrade it. And that is a good choice. So the solution is this. When you log into a website, you need to put in your username, right? While you're typing in the username, that's when you go ahead and spawn this iframe, populate it with the HTTPS, preload all the contents, and then when they hit the secure site, then they hit the password, when they hit the stuff that they shouldn't be putting in publicly, bam, you move them over. It's great. I'd give you a demo, but there isn't time. The code is really straightforward though. We have a username field that runs the pre-cache function. We have a password field that as soon as it's focused, switches the page over, and we have a span called the text ID. It looks like we're actually getting a video for the other side. This pre-caching, what it does is a singleton. It'll only run once. You only want to be launching that iframe once. You don't want to fill the page with it. But all it does is it goes to the text display, the little span, and it throws in an iframe. What does this end up looking like? Well, you do a username password field. As soon as you type in ABCD, bam, you go ahead and that iframe opens up. As soon as you go to password, you redirect over. Great. Now can we stop abusing SSL? Woo. As long as we're talking about bugs in crypto systems, I'm kind of sort of responsible for one. I mean, not really, but kind of. So was anyone actually at my SSH talk 6 years ago? Holy crap, that's awesome. Seriously, I'm surprised I was there. No, So one of the things I found, SSH being a crypto system that allows you to connect to random hosts on the net, not random, but your host, do it securely. I found instead of just getting a shell, instead of just getting a text link, you could actually move arbitrary web traffic, IM, all this kind of good stuff. You can basically get like a poor man's VPN link. Now the problem is when you do this with SSH, it was actually leaking DNS locally. DNS being a subject that I took up a few years later. Now what I ended up doing at the time, a couple years back, is I got the OpenSSH guys to add support, not for SOCKS 4, which doesn't support doing remote DNS, saying, I'm not going to give you an IP address, here's a name, you look it up. I said support SOCKS 5, which allows you to put in a name. And the OpenSSH guys did that, and through an undocumented option, Mozilla supports it. But not all clients IE7 support this. So is it possible to fix things like IE7 without going through the code? And the answer is yes. Why can't we forward DNS over TCP? SSH directly? Well, you see, DNS is a UDP-based protocol, just individual messages that fly back and forth. Now, we could put a huge translation layer in where it receives UDP packets and it runs NS lookup commands, and it's this big, ugly mess. We could do that, and then Theodore Rad would look at the code patch that I'm suggesting for OpenSSH and be like, I'm going to shoot you. Or, it turns out DNS will run over TCP. You just have to tell it won't work over UDP. So you put up a silly little server that all it has is just, oh, you're coming to me over UDP? No, that isn't going to work. Truncation bit equals 1. And the thing goes, oh, well, let me retry that over TCP. And that SSH can move just fine. This is a nice general purpose strategy for anything that's trying to use SOCKS in an environment where the client doesn't necessarily support it. Works well. Sadly, I'm totally going to hell because, I got DNS over SSH here, and later I got SSH over DNS, which means DNS over SSH over DNS means, yes, guys, I finally did implement DNS over DNS. Malkovich. Okay, I eventually have pretty pictures coming. So, wetware bugs. SSH has another problem. The authenticity of law 1.2.3.4 can't be established. RSA key fingerprint is 09A9B199841777D, etc., blah, blah, blah. Am I supposed to do something with this value? Okay, seriously, crypto designers look you straight in the face and go, yes, that is a shortened fingerprint. It's only 160 bits long. And you're supposed to recognize that, and you're supposed to reject it if it's not what you're looking for. Okay, I don't know who these guys are. I can't do that. And in fact, ADM did what's called the 2 billion SSH key attack, where you generate 2 billion proposed keys, and you just send the one that's visually the most similar. Does it trick people? Trivially. So, new field, I'm calling it cryptonamonics. The actual study of how you remember cryptographic variables. Anyone here still in college, by the way? Cool. Take some psych classes. Seriously, they're rather useful, even for the hacker types. So, what time is it right now? All right, 10:30. 3 classes of memory that are useful for cryptography. A, rejection. I've never seen that before. B, recognition. It's that one, not that one. I'm like, dude, recognition isn't that cool. What? Ah! Well, equal time. What would you do with $1 million? 2 screens at the same time. So, rejection, I've never seen that. Recognition, it's that and not that. And recollection. Here, let me just tell it to you. The way the human brain works, we have much larger capacity for rejecting stuff than we do for recognizing, picking out of a lineup, and we have even less ability to remember passwords for recollection. So if I can look at a password and be like, yeah, that's totally my password, and that one isn't, that one is, but if you actually ask me to come up with some sequence of letters, it's a lot harder. So you can actually take this down to our entropic representation abilities for certain signals. Whatever, let me just move on. We don't have time for me to figure out how to say simple things like sentences. There have been other attempts to make alternate representations of cryptographic entropy. Abstract art was used by a mechanism called deja vu, where they use computer-generated artwork. And you can see that in the upper right corner. That is some good timing, by the way. Then there was another mechanism called passfaces that actually used dynamically generated faces. This attempted to move the problem of passwords from what people were typing in, recollection, which is very limited, and tried to move it to recognition. Pick the one of these that you recognize. Now the problem is that the amount of entropy that we can actually represent in pick the one that you recognize, surprisingly small, less than 2 to 16. Now this is okay, because passfaces is an online attack, or online mechanism, and thus the user can be locked out, or an attacker can be locked out before their 59,000 tries are up. But SSH's requirement doesn't work like that. It's showing you a fingerprint, and offline you get to do whatever you want to try to break it. So we need something else. So what do we know? Oh yeah. Humans do not remember arbitrary strings of characters effectively. We know that failed. We do know that our brains can actually store a surprising amount of entropy. Homer's epics are enormous. We can certainly remember stories. But stories morph over time. They change, they go back and forth. It's actually a challenge for stories to stay stable. Our ability to reject a story that's changed a little is pretty low. But you know what's really stable in stories? Homer. Like the guy, Homer. Like the actual name. Names are an incredibly stable thing for the human mind to remember. They're the most stable entity in any kind of story. We seem to have some hardware or wetware acceleration for them. So what if we represent rejection proposals, instead of as a series of bytes, which we know is a failure, what if we represent it as a series of names? This is really weird, but I swear to God it works. So first, we take US Census data for names, which is available at the US Census. We note we have to have quite a few more female names than male names available. So what we do is we take 512 male names, 1,024 female names, and 8,192 last names. That's 9 bits, 10 bits, and 13 bits respectively. Now, we don't just take these names randomly. We attempt to determine we tend to get the most dissimilar names possible. We use what's called the edit distance, the amount of operations required to go from one name to the other. And what we try to do is we try to maximize the difference between every name that we pick. Because what we want is, if someone sees Bob and not Mary, we want them to see, wait, that's the wrong name. I don't recognize that. Or I'm going to reject that. That's what we're going for. I'm telling you details about edit distance because it becomes really useful later. But there are also some other acoustic measurements, like the old SoundX algorithm or metaphone that the linguistics guys have come up with. But edit distance seems to work really well. Well, now we've got ways of representing 32 bits of information in chunks, and actually married couples. So yeah, you can take 160 bits and split it into 5 married couples, and it kind of looks like that. Instead of a big string of bytes, you get Julio and Epifania Tezzuti, Luther and Rolanda Dornbos, Manuel and Twyla and Bessie. You have to show the names to your users every single time they log in, not just when something may have gone wrong, but it's shocking. It works. I spent like 6 months SSHing to every host that I went to with this. I could tell which one was the ones I knew and which ones wasn't. You just recognize the names. You might say, oh, but I'm bad with names. No, you're bad with names because people say their names really quickly, never say them again. If you're actually repeated, you actually start to remember names pretty well. Speaking of broken representations of entropy, OD-XTX1 foo. Nice little hex dump of a file. Wow, 6AAC06. This is about just as useless. Oh, but no, we've got a star. It's saying that this line has been repeated. Look at all those zeros, man. I really have lots of analysis of my arbitrary data here. There's got to be a better way to look at random strings of hex. And no, adding ASCII isn't enough. We need better ways to look at arbitrary data. For data analysis, first view of looking at new protocols. What can I say? I love me some new protocols. And of course, fuzzing. So, what's the deal with fuzzing? We've got 2 main kinds of fuzzing out there.